Now we have a panel discussion just for 30 minutes, so please welcome back to the stage Andreas from ESA, Bob Lamboray from the Luxembourg Space Agency, Edgar once more from NASA, and Kathryn Hadler, ESRIC, of course. To make sure everybody has a microphone. You do. Well, thank you so much. I think we've heard from everybody apart from you, Bob. So would you like to introduce the Luxembourg Space Agency?
Hello. Yes. So good afternoon, everyone. I'm Bob Lamboray from the Luxembourg Space Agency, Senior Manager for Exploration and Space Resources. So I lead a lot of the initiatives and projects we support at the agency in this field. I'm happy to share a few more details later.
Thank you. Well, I'm going to just jump first of all to Andreas, to ESA actually. So obviously I've been doing a little bit of research about you, and I know now you're head for human exploration, the group leader there at the European Astronaut Centre. But when I was reading about you, part of your work, your physical work, was underwater. And I know we're talking about space, but I just wanted to throw in a thought, first of all. Why did you not think about exploring underwater before going up that direction?
Well, to be honest, I've always been fascinated by exploration. I think there's something very natural that appeals to humans. I mean, we are born as children with a natural curiosity to explore the world around us, and I think for many of us it carries over into our adult lives. It certainly did for me. Looking out at the night sky and seeing the millions or billions of stars has always inspired me, principally because there must be incredible opportunities and incredible discoveries waiting for us. When you look out at such a vast universe, I mean, the imagination is the only limit, really. Yeah.
But coming back now to your work at ESA, thank you. The reason I ask about that is sometimes people say we're doing all of this work towards space, but actually we've got huge amounts of oceans and undiscovered things underneath.
And maybe that's an important point to also bring up. I mean, we talk, as you say, about space exploration, but space exploration is more than what we see when we look up at the night sky. Space exploration is also the exploration of the Earth. I mean, a lot of what we do in space is directed at understanding our home world. And the further out we travel, the wiser we become about our home planet. I'm certain of it. And I think when we learn to set up a moon base, and when we learn to live on the moon, we will gain knowledge and technologies that will benefit us here on the Earth. I mean, sustainability will be a key aspect of any lunar base, and that will be directly applicable to us and our society on Earth.
We heard from Edgar the higher cadence, the tempo, all of these musical terms actually that you're bringing out. The flight tempo has to be quicker. And now with ESA, 23 member states, you need the buy-in. So what is the cadence, the tempo like with ESA?
Well, I think, at ESA and in Europe, international collaboration is in our blood. We have to collaborate, and there are, advantages and disadvantages. One disadvantage is that we have to take the time necessary to convince all of our member states that we're moving in the right direction, and to also get everyone to move in the right direction. But I think it's also a strength.
But taking time is also an economical consideration. And so where is that balance between making a decision and making it economically viable?
Well, I think if there's one thing we've learned from the International Space Station is that international collaboration makes the entire program much more robust. When one partner has a challenge, other partners can step up. And that's what we see within Europe as well. When we pool our resources, when we all pull in the same direction, what we together as Europeans can achieve is remarkable. Certainly much more than what we can achieve individually as countries.
Thank you, Andreas. Thank you. Well, let's turn to you, Edgar. And again, you were talking about the wonderful success of Artemis 2, the absolute certainty you will be building a moon base. The phase 3, that approach is different. So let's talk about, just to broaden it out a little bit more, the changing vision, that change in tempo, and how you're redirecting, because it takes, decision-making takes visionary leadership, but it means the whole team has to come behind that decision.
Thank you. So I think going into this higher tempo approach challenges us in not only having that long-term vision of wanting a moon base, but how do I change my behavior? How do I change my rules? How do I change my partnerships in order to get there in a more disciplined way, a more sustainable way? So when I think about this opportunity that we have in front of us, there's a lot of changes technology-wise, but also in the way that we operate that has to change. I'll give you a silly example. Artemis 2, we had a new administrator that was announced not too long before the mission, and he comes in and he says, I want a new iPhone on the flight. Now, the iPhone we had certified was a 12, and it had gone through extensive testing about making sure it was compatible with environments, making sure the batteries were not going to burn up. But all of that was our norm. We were ready for the mission. And here somebody comes in and says, I want a new iPhone. You have a week to do it. The first answer, of course, by everybody is, are you crazy? You know, there's so much that we have to do, our disciplined way of approaching. But it took direction to go change. All right, so how are we going to do that? And you break down the problem and you turn people who say it can't be done to people who say this is how I'm going to do it. And then you do it. And you get comfortable with, okay, what areas did I take risk? Was that an appropriate risk to take? How do I make sure I don't do anything that is wrong, in which I have to go push back? So the people are changing just as much as the technology. And that is sustainable. That will be the way, to me, that I look at the opportunity that exists in this approach to a sustainable moon base, of getting there in the amount of time that we want, and getting this higher cadence to actually be real with real experiments. That's what I'm looking forward to in going in that direction.
And which iPhone was it in the end? Which iPhone did get up there?
It did. It was a 17.
17.
17 made it. You saw it floating around, too.
What wonderful advertising for them. Bob, moving to you now. Of course, Luxembourg Space Agency, in existence not so long, but long enough to see huge change happening. And it really is rather remarkable. So talk us through the progress, especially regulatory progress.
Yes, so I think overall, since we launched the initiative 10 years ago, we have made a lot of progress on many different levels. When we started the initiative, we laid out different challenges that we want to address in parallel that come with the use of space resource. And I think one aspect is the regulatory part, where it clearly came, the ISIU or space resource came from a more controversial concept, and nowadays it's part of any exploration strategy. It's definitely not on the critical path, but it's a very important element as we go back to the moon. And the place where you can really see this shift from a more controversial, skeptical topic is in Vienna, where we discussed the regulatory frameworks, where 10 years ago, the topic was not well known, and overall the discussions was a lot about, is it even legal to use space resources? And this evolved now into a discussion, what actually is the framework we need to do so in a responsible and sustainable way. So it clearly shows a bit this transition from a niche topic to it's accepted that it should be used, should be able to use space resources. Then also, I think on the national side, we also saw very impressive progress on the industry side. We had recently 2 years ago, we had the first mission by iSpace that launched the first rover developed and built in Luxembourg, flying to the moon with an authorization under the national space resource law. So these are two examples showing a bit the progress we saw over the last 10 years.
And I think perhaps another thing to underline is the fact that Luxembourg was one of the first signatories with the Artemis Accords, and now there are about 64 countries.
Absolutely. So we were one of the first 8 signatory countries that supported the Artemis Accords. They address specifically, they have an article dedicated to space resources, stating that they are important for safe and sustainable, acknowledging that the space resources are important for safe and sustainable exploration, that it should be able to use it, that it should not be, now it becomes a bit technical, considered as appropriation by itself, by using their space resources. And in the meantime, we have 64 countries that have joined the Artemis Accords, and it clearly shows a bit how broadly these principles laid out in the Accords for a responsible, safe exploration, how they are getting adopted across the world.
Now, I know one of the big topics of conversation in Europe at the moment is resilience and sovereignty. And so how does the Luxembourg Space Agency think about that for Luxembourg and then more broadly across ESA as well? Can Europe be resilient? Can Europe have sovereignty when it comes to space?
So I think for Luxembourg, being resilient by itself, it's a difficult topic. I think we need to do this in a community, especially as a small country. I think international collaboration is extremely important. We are a member of the European Space Agency. I think we are very committed to develop this topic together in Europe with the European Space Agency. Luxembourg made by far its largest subscription to the European Exploration Program recently in November last year. With the idea or with the ambition to develop the MACPI mission together with our Japanese friends to further strengthen the collaboration with ESRIC and then also develop these activities across Europe. So I think for us it's very important to do this on one side with the international community, and on the other side I think in Luxembourg is also the commercial side always has a very important element in this. We believe that it's important to do it together with commercial actors, because they are actually the ones who will be able to turn all these concepts and ideas into a long-term sustainable presence on the moon.
Thank you, Kathryn. Sorry to leave you to last, but we'd heard from you before. But really bringing it all together, ESRIC, of course, is a combination of LSA and also ESA as well, and LIST here in Luxembourg. You are also a teacher of PhD students. You also are bringing up the next layer of researchers to work within space resources. But the topics are broad, so how do you think about which topics to cover?
That's a very big question. I teach space resources to the Masters in Space Technology and Business at the University of Luxembourg, and as you quite rightly say, I supervise PhD students. It's a really difficult subject to teach, and we see from the professional course as well over Saturday and Sunday that Angel led, and with the guest speakers there as well. It's such a broad subject, and I think I said in 2022. It was my first Space Resources Week as director of ESRIC. I'd been in the job for a month, but I'm pretty much sure I said that something at the time, like the whole field is a gap. It's not about finding research gaps, it's actually the whole thing is a gap. There's so much that's still to do. But then trying to find the areas to focus on, what we should prioritize, is incredibly challenging. We see some areas that are attracting more attention now. So we have more focus on prospecting as a near-term activity. There's a lot more activity now on lunar regolith handling, which is beneficial for construction, oxygen extraction, and so on. But the field is so broad, diverse, and rich, and there's so much to do that it lends itself to a lot of research that needs to be done.
And the reason I ask that is because the talent pool is what feeds into the whole system coming up. Everybody that's going to work within an agency or build their own spin-out business, which is also rife here in the room in a wonderful way. And so how do you think about that when you're planning the vision for ESRIC? Because that is your future pipeline.
Well, ESRIC's research, when it started, when we started 5 years ago, was focused on the ESA Space Resources Strategy of 2019, which was based on oxygen extraction from regolith. And you see that now in the research that we do, you see the results of that focus. So we do look at regolith handling, oxygen extraction, use of metals, water purification, and so on. But there's... Oh dear, it's like a sign. But there's so much more that can be done, and that we don't do, because we are a research and innovation centre currently of 30. We're still growing, but we also need to maintain focus. And what we look for if you look at the team that we are from all science and technology disciplines. It's very multidisciplinary, and we need that multidisciplinary approach to support all of the needs of the sector.
We have a few more minutes left here, and so I don't know if anybody has questions. Yes, hands shot up right in front of me here. If we could quickly have a microphone here. Thank you very much.
Thank you. My name is Mel Gelderman. I had a question for Edgar Castro. There's a lot of, you're in Europe right now. We're all very excited about returning back to the moon. The question is, for entrepreneurs in Europe, how could we bid on contracts that NASA is offering? And will we be treated differently than US companies? Thank you.
Tough question. So I think I've heard it a couple of times now. We are not going to do this alone. We're going to succeed through this by doing it together. One of the things that I found very exciting was when all these requests for information to this new ignition approach came out, it specifically asked for input from academia, from our international partners, from industry, about what would they like to see as this demand for how do we go execute the next several years. And so we're asking questions. Some people will tell you, I already know the answer, and so why am I spending time with the question? No, that's not what's happening now. The questions are getting re-asked to validate and point. The second thing I would tell you is the framework that's out there is one that will allow for entrepreneurs and ideas that come in for proposals to all these flight opportunities. The information I've gotten to date is there's a percentage of them that will be set aside to directed, hey, I know I have a technology gap, I know I have a data gap, and here's a good investment that we've made in several years to go finish. But then there will be several that are open for competition for innovative ideas. And if you look at that tempo that's up there, that tempo is one that is going to require, I think, offerers to be able to say, I have hardware in hand, close in hand. It may not be the end-to-end system. It may not be the right systems engineering total answer, but I can prove this small piece of a technical challenge that's out there. And it'll be a building block that an entrepreneur comes in, hey, I think I have a good oven solution. I think I have a good electrostatic solution. I think I have a really good dusty connector solution. And it'll get the visibility, it'll get the opportunity to go prove out its performance, and then maybe it becomes part of a larger rover. Maybe it becomes part of a, survive the night solution as a component for it. So with that tempo, I think those opportunities are coming in, you get to bid on them, you get the visibility of demonstrating your success, and then that can grow into hopefully something bigger.
So effectively, there's no bias.
I think it is open. I really do.
You have a follow-up point.
You're saying that the major parts of the contracts are going to be US based, but then smaller subsystems European companies can compete for as well.
He didn't quite say that.
No, I didn't quite say that, because I'll be honest, I don't know the answer to that. I don't know. I think we're still in some formulation about what is going to be that path, but I do know, I've heard my bosses say, hey, it's not, we may not get it right the first time. Phase 1 is about some specific approaches to technology gaps, and then that may lead to something else downstream. So how many of those are allocated to, okay, am I doing a pressurized module? Am I doing a unpressurized rover? Some of those major elements are out there. Logistics carriers, ISRU plant, those, I think we will develop those as we go through the phases.
Thank you. Further questions from the audience? We've got a few more minutes. We've got time for 2 or 3 questions from the audience. Yep, we've got 2 questions over here. If we could have quick questions and quick answers, that would be great. And if you could stand up, that's also great. And introduce yourself.
Hello, I am Daniela, a chemical engineering student from Mexico. And my question would be to Kathryn Hadler. And I would like to ask, what would you recommend me as an international young student to obtain before applying for a master's or continuing my studies in these fields?
Do you mean what subject?
No, like if I am a young student and I want to start in this field, as my background is multidisciplinary as well, like chemical engineering, but I don't have like a space degree or something, but I want to continue here. Like what would you recommend to obtain, like a motivation letter from my teachers or stuff? Like maybe my question is, us as students, we don't have so much preparation, like not that we don't have so much preparation, but that the getting into the space field sometimes can be a little bit scary, or sometimes can be seen as it is too far away for students that they don't have a spatial.
Okay, thank you. Okay, so the question really to all of you is, where are the gaps? Where are the talent gaps? And what could young people do to get into the space world if they're not engineers?
Can I just start for a second? I mean, firstly, in my opinion, you are the best kind of engineer, which is the chemical engineer. I'm a big fan of saying this. There's not enough chemical engineers in this field. As a chemical engineer, you will also see Jun Shimada from JAXA. He's also a chemical engineer. And there's several others out there. You just have to look for them. Actually, we do need people with a broad range of backgrounds in this field. If you look at if you go and talk to the people with posters, or you talk to the people who are doing masters or research PhDs, you will find they come from a broad range of disciplines. So I think sometimes not having an aerospace engineering background is not a hindrance, certainly, to get into this domain.
And for both NASA really and ESA, where are you seeing the talent gaps?
Let's see. So
either of you can jump in.
I'll jump in. I would tell you, to what I see today that is really differentiating students coming in is a lot of internships are out there where they're getting practical experience. There's a lot of pivoting that happens once you're in the field. And so once you go in, you're discovering where the opportunities are, and you're taking advantage of what you know, and you're bringing that perspective to a totally different area that makes a lot of sense. And so it expands our thinking of how to go solve problems. I don't want all aerospace engineers. I don't want all chemical engineers, okay? But they work great together. And so I personally really favor internships where they've gotten that growth and working as teams, they've gotten multidisciplinary discipline problems, has been working fantastic.
I think that's really, really good advice. Don't get too hung up on the end goal. Take the opportunities that arise. From personal experience, I always wanted to work in the space industry, but it took a detour through the oil industry, working on offshore oil rigs in West Africa before I made it to my final destination. But like Edgar said, anything that challenges you, brings you more experience, you often find a way to bring that into, or it helps you on your way to achieving your final goal.
Thank you. Lots of inspiration for you there. I think there's a question just behind you.
I'm Alexander with Intel. It's an honor to be here, by the way, but I had my initial question was how much consideration has been given to lunar resource regolith, the byproducts? I know there's focus on oxygen, tungsten, other precious metals and resources, but one of the most popular byproducts here on Earth is sand. And sand, we have silica. We use silica to make silicon. Silicon makes chips and manufacturing products that Intel makes today. I'm curious how much consideration has been given to the other byproducts that are involved with regolith on the moon.
I didn't quite catch all the words.
I think I got it. It's about byproducts, right? Byproducts from the useful, from the focus. Am I correct? Yeah? Actually, you know, at ESRIC, we have a PhD that's coming to completion. If you see a really exhausted looking person around, that's the PhD who's coming to completion. Anyway, he's doing a project on the use of metal byproducts from oxygen extraction. And actually, there's another person from Politecnico di Milano who's doing a similar project as well. So actually, there are active research projects looking at uses of metal byproducts from when we extract oxygen from the regolith. But in general, when you look at the research that's going on, we look at the use of all products because everything that we're using will be a resource. And we're in a resource-scarce environment. We must make sure that we are maximizing the use of everything that we produce. So there is a lot of research out there, including recycling and so on, that you will find on all uses of resources.
We've got about a minute and a half left. Any further comments or questions? I think these questions are getting a little bit technical. If you've got very technical questions or very precise questions, then I would go directly to the speakers, and they're all very friendly. I can assure you they're very friendly. You don't need to worry about anything. And it's really wonderful to have students in the audience, actually, people who want to be involved. And I think one thing you learn from the next 4 days, if you stay, and I hope you stay for the next 4 days, is it's massively interdisciplinary. There are so many fields, so many subjects, and everybody is welcome. So you have an extra minute for the coffee break, and so we will start back in the room at 4:10. Thank you very much. Thank you to the panel.